Hello there. Welcome to this video on using the hardware such as resistors, capacitors, transistors, and more. In this video, we're going to see how these electronic components become an important part of any production design. We're going to see its working, applications, and rating. Now, if you take any electronic device and if you open it up, you're going to see something like this. You're going to see capacitors, resistors, transistors, perhaps relays, transformers, microchips, microprocessors, and so on. In this video, we're going to see a little bit about all these components and get familiarized with them. Alright, the first major distinction between them is how a regular component looks like and how an SMD component looks like. SMD stands for Surface Mount Design. Now, the major difference between these two guys is the size, of course. You see that these are the actual images, and a regular resistor or a regular component is quite large, and an SMD component is very small, can be extremely small. As you can see here, these are the actual sizes, and of course they come in different sizes. Alright, now let's take a look at resistors. Resistor is basically a passive electronic component, and it has a certain function. It restricts the flow of current through it. So for example, if you have a 3-volt supply and if you have an LED, you most likely should have a resistor before the LED. Now, the LED has a rated voltage and current. So if the supply voltage is greater than that, or if the supply voltage fluctuates, then obviously your LED is bound to be damaged or even broken. So in order to maintain that and protect your device, you definitely need to have a resistor. Obviously, when you're playing around with your LED on the Arduino boards, because it's only 5 volts, you really don't need to worry about it. But in an actual production design, you will definitely have a safety component like a resistor. You can also use resistors to act as a fuse. So for example, if you have a resistor with a specific rating of watts, and if the supply is very heavy and the current is very large, then your resistor will burn and the circuit will be open. So anyway you look at it, the resistor's main job is to limit the current and protect your circuit and its components. Now, resistors come in different values, and resistors go by the unit of ohms. The way to read the resistor's value is by understanding its color bands. Now let's see how to read the color bands. Now if you place a resistor like this, which is the thin line on your right hand side and the others on the left hand side, you will get 3 color bands, and including this one, you're going to get 4 color bands. So the first color band should be read like this. So if it is black, it's going to be 0. If it is red, it's going to be 2. And if it's white, it's going to be 9. The second band is very similar to the first band. The third band is a multiplier. So basically, for example, in this case, the first band is red, so 2. Second band is black, so 0. Third band is red, so into 100. So therefore, 20 into 100 is 2200. Your tolerance is plus or minus 5. Alright, perfect. That's pretty good. And now let's take a quick example. So this is the resistor you're gonna read. So let's go from the left. You have yellow. So if I go back, yellow is 4. And next is violet. Now if I go back, violet is 7. And you got orange. Orange in this case is 1K. So therefore, you're looking at 47K. And the tolerance is plus or minus 10. There you go. That's how you read a resistor. Capacitors are passive electrical components. They're basically 2 plates divided by a dielectric component or a material. They behave pretty much like a battery, so they charge and discharge. Capacitors are of different types, for example, ceramic, like you see here, and electrolytic, like you see here. Now, the electrolytic capacitors are polarized. So there is a positive and a negative. The negative is called as a cathode, and the positive is called as the anode. You can identify the negative lead by the height of it. It's shorter generally, and it has a black strip to identify. The anode is generally longer, and there is no black strip. If you by mistake reverse the polarity, your capacitor will blow, and that could be dangerous. So be careful. The applications could be decoupling When you have a standard voltage which is not constant, then a capacitor can help you to maintain a stable voltage. You can use capacitor to filter certain frequencies from your voltage. It plays a critical role in converting AC to DC. It can be also used as a bypass component to your source voltage for a small amount of time. The unit of capacitors is farad and volts, that is how much voltage it can carry. Diodes are semiconductors, and there are different types of diodes which you can use depending on what you're going to use them for. Let's first take a look at the power diode. Power diode works pretty much like a check valve. It allows the current to flow in one direction, and it does not allow the current to flow in the reverse direction. Then there is another diode called the Zener diode. Now this is a special diode which allows only a certain level of voltage to pass through it. For example, if you buy a Zener which is rated as 5 volts, then it'll only allow 5 volts to pass through it. Then you have the ubiquitous LED, which is light emitting diode. So when you give a voltage, it produces light. Then you also have the photodiode, which works in reverse to the LED. So when you apply light, it produces a small discharge. The ratings are volts and amperes for power diode. For Zener diode, it's volts and watts, how much power it can carry. LED is generally in millimeters, and photodiode is in wavelength and area. Let's take a look at some applications. Power diodes are heavily used to restrict the flow of current. They're used majorly in the AC to DC conversion as rectifiers. Zener diodes are used only to allow a certain voltage, so they're used as voltage regulators. LED is used to produce light, and photodiode is used to detect light and also plays a major role in the solar generation. There's also another option to regulate your voltage, which is using an IC based voltage regulator like this one, which is an LM7805. The applications are similar, which is to regulate the voltage, protect your components, and in some cases also to step down the voltage. The rating is volts and current. Transistors are semiconductors widely used in electronics. For example, your hard disk has millions and billions of transistors. There are fundamentally two types of transistors. One is NPN and PNP. Both of these have 3 terminals. Let's take a look at NPN. Here the 3 terminals are B for base, C for collector, and E for emitter. The base here acts like a switch for the current to flow between the C terminal and the E terminal. So you have a positive at C, then you have a load, and then you have a negative on the E. Now by applying a small charge at the B terminal, you will enable the C and E terminals to conduct, and therefore your NPN will work as a switch. The PNP transistor works in reverse of the NPN transistor. These are made in different ways. BJT, which is bipolar junction transistor, FET, which is field effect transistor, MOSFET, which is metal oxide silicon FET. Transistors are widely used as digital switches. They can be used for decoupling and isolation, which is separating the high voltage from the low voltage. They can be used for amplification and so on. The rating is in volts and current. Relays are electromechanical devices, and they also act as a switch. They also can perform decoupling and isolation. Now the difference is these are electromechanical in nature. So these have 3 terminals. Just for understanding, let's name it as A, B, and C. You connect your load across A and C, and there's a small voltage which is basically 5 volts which you need to give at junction B, and your A and C will conduct, very much like a transistor. The rating is also in volts and current. When you're making a prototype or assembling an IoT device, you always are going to be using jump wires. The one you see on the top is called as a female. You see that it has no protruding lead, and the one at the bottom is called as a male. So you have leads protruding. So generally a male would go into a female and so on. So there is different combinations: male, female, male, and so on. On the right hand side is an ammeter, or at least what looks like an ammeter. Ammeter is something which is very important for you to measure current, voltage, to measure resistance, capacitance, and so on. It is something which every one of us should have. Well, I hope with that you got some fundamental information about the electronic and electrical components which you might be using in building your IoT devices. In the next video, we're going to see how to set up your Arduino IDE. Thank you.